I see 1 o'clock, and so we will begin. The committee is back in session.
Okay.
I'm going to introduce you, and then you will have the floor for as long as you want. After you finish your presentation, we will have some questions by members. I'm going to have to step out. I'm the chairman. Representative Gus Blackwell and Representative Fisher will conduct the questioning and introduce the next guest. So with that, yes. Do you have an agenda? It was on the meeting notice. I will go run a couple off and bring them back in here in a second. And I'm not exactly sure I get your name right, but we'll take a stab at it. Dr. Ze'ev Worman was a U.S. Department of Education official under George W. Bush, is currently an executive with Monolithic IC3D Incorporated. In 2010, Dr. Worman served on the California Academic Content Standards Commission that evaluated the suitability of Common Core standards for California, and is co-author with Sandra Stotsky of Common Core Standards Still Don't Make the Grade, Pioneer Institute 2010. With that, Dr. Worman, you are recognized.
Mr. Chairman, committee members, thank you for having me here and allowing you to testify in front of you. I'm pleased to speak to you without having to travel long distance. I have been traveling a lot in recent months, so this is a luxury that I'm grateful for. My testimony today, I will focus on the following points. The mediocrity of the Common Core standards, the low level of the Common Core's definition of college readiness, and that the argued benefits of national standards are weak and uncertain, while the major increase in cost of assessment, the loss of state autonomy, the loss of public review, and the loss of educational innovation are real and immediate. Let me address the first point, the quality of the Common Core mathematics standards. The Oklahoma math standards have been rated highly by the Thomas Fordham Foundation, Fordham Institute, and they are essentially indistinguishable from the Common Core rate. Well, that should tell you something, because if your standards are essentially as good as the Common Core has been rated, yet your achievement had been mediocre. Does it say that the importance of standard is so high that everything has to change to adopt newer and higher or supposedly higher standard? The answer is clearly no. Standards are just one component in educational achievement, and it's important to have good standards. But it's also important to have aligned systems, to have the buy-in of everyone around, and to have it tuned to your own students, teachers, and educational establishment. The Common Core claims that it's very focused, very coherent, and it is narrowly focused on very few topics in each grade so they can teach them in depth. Yet, if one looks at other countries that are very high achieving, like Singapore or Korea, they are very highly achieving, as I said, yet their curricula are not that narrow and that focused. Yes, they are much more focused than some notional, very wide and mile wide and inch deep curriculum that sometimes is mentioned here in the United States. Yet this idea that our curricula and our standards are mile wide and inch deep stems from the 1990s, where many of our state standards either didn't exist or indeed were very fuzzy. Yet more than 20 years have passed since then, and many states, including yours, have refined their standards. Our standards today are not mile wide and inch deep. They are comparable to the best of them. Let me give you some example of the things that the Common Core standard jettisoned in the rush to be seen as lean and mean. An example I like to use is the issue of money. Everybody understands that starting early with the concept of money for children is very helpful because children have innate curiosity about money. They also have some understanding that they gained at home about coins and bills, and one should build on it. And that's why your own standards and Singapore and other high-achieving countries start very early with the concept of money and coins. Yet Common Core deferred it to the second grade only, much too late. And therefore, they start teaching on numbers without using this wonderful scaffolding. Another thing that Common Core, trying to be so lean and mean, forgot is to teach prime factorization, very fundamental element of how the numbers are structured. They completely forgot this part, and consequently, they cannot talk about least common denominator or greatest common factors because those are relying on prime factorization. Even when they teach fraction, which is what's supposed to be their strongest point, the Common Core standards completely forgot to teach conversion between different forms of fraction. The regular fractional form, or so-called the common fraction, percents, and decimals. This is a key skill that has been frequently talked about both by the NCTN, National Council of Teachers of Mathematics, by the National Research Council, and by the National Advisory Mathematics Panel that was established by President Bush 5 years back, and they also mentioned it as a key skill. Yet all this is missing in the Common Core standards. The truth is that the Common Core was put together pretty rapidly and in the rush. They didn't have time to do a very good job. It's not that the people that did it were not wise or intelligent, but they were under time pressure. They had to do something so it would be ready for the race to the top, and the results show it's really not ready for prime time. There is another point that maybe it's worth mentioning. Many proponents of the Common Core point out, and correctly, that the Common Core does call for fluency with the 4 arithmetic operations, which many state standards do not call for explicitly. And this is true. Indeed, the Common Core does call for this fluency, although they call for it a year or two later than our international competitors and many other state standards. Well, you could say better late than never. And indeed, it is better late than never. However, this is not as innocuous as one might think, because it allows for additional year or two of exposing students to a variety of invented algorithms, of individual ways of trying to solve arithmetic problems. And this really confuses them, because when they eventually come to the standard algorithm, they frequently do not understand the importance of the standard algorithm and the efficiency of standard algorithm as compared to the strategies and the invented algorithms that they have been fed for previous many years. So the result is that while the fluency with standard algorithms is mentioned in the Common Core, I expect very few students actually attain this fluency. They will know about it, but they will see it on par with many other invented algorithmic strategies that may or may not work in different cases. In fact, Professor James Milgram, who was a member of the Common Core Validation Committee, noticed this, and he observed in his testimony in front of the California Academic Standard Commission, and quote, within the document itself seems to be a minor war going on, and this is not something we should hand over to our teachers. This minor war between, on one hand, the standard algorithm, and on the other hand, the strategies, the invented algorithms, and essentially effort to have students discover their own ways of mathematics. The result of it, as I said, is not innocuous, and because the Common Core can be read multiple ways, because the language is so unclear and has different sections in different grades, different kind of textbook can claim that they are aligned with it. And they can say with straight face that whether they are on the extreme reform side, very fuzzy, or they are very rigorous, very traditional, both of them could claim they are aligned with the Common Core. So that label, aligned with Common Core, actually means very little. And this is another danger. But perhaps the biggest marker of the low level or mediocre, not low level is possibly too strong, but mediocre level of the Common Core is that it does not expect middle school students to take algebra by grade 8. Not every student is expected in every state to take algebra by grade 8, and this is fine. You cannot expect students to do it unless they're well prepared, and not all the students are well prepared, we know that. However, this has been the goal of our system in the United States for over a decade, to push more and more students into taking algebra earlier so they can actually take a more advanced mathematics in the high school. This has been the recommendation of the National Mathematics Advisory Panel. This has been the push of all of the educational establishment. Yet the Common Core abandoned this goal, and they directly pushed algebra as a high school course. This is a clear sign of the lowered expectations that we in the Common Core holds for our students. Now, many of the proponents will say, but we put some algebra in grade 8. Indeed, they did. But that's what made grade 8 essentially a pre-algebra. What is a pre-algebra? It's a math course that has some bits and pieces of algebra. And that's really what grade 8 Common Core mathematics is. Again, the evidence is that there is an Algebra 1 course, but it's not in the middle school, it's in the high school. So by their own tacit admission, algebra is moved to grade 9, even though they try to cover it up in some way, saying, oh no, we do tend to have some algebra in grade 8. I would like now to move to, rather than from the specific to the more general. There have been a handful of studies done to compare the Common Core to other nations and other states, high-achieving nations, high-achieving states, and find how well does the Common Core stand up to them. Dr. Sandra Stotsky, who you will hear soon, and myself, we did such a study in 2010, and our summary conclusion in mathematics was as follows. Common Core project was a laudable effort to shape a national curriculum. Unfortunately, rather than build on the strengths that can be documented in Massachusetts or California, the draft writers chose to navigate an uncharted path. Consequently, although they sometimes include an interesting treatment of several new ideas that are potentially useful for the development or implementation of a standard, by grade 8, their standards are a year or two behind the National Mathematics Advisory Panel's recommendation, behind leading states, and behind our international competitors. In other words, we found them weak. Dr. Jonathan Goodman, professor of mathematics at the Courant Institute at the New York University, also studied and compared the Common Core with international high achievers, and his conclusions were, the proposed Common Core standard is similar in earlier grades, but has a significantly lower expectations with respect to algebra and geometry than the published standards of other countries I examined. The Common Core standard document is prepared with less care and is less useful to teachers and math ed administrators than other standards I examined. In other words, again, Professor Goodman found them lacking compared to international competitors. I mentioned Dr. Milgram, who was also on the Common Core Validation Committee, and he did his own study as part of this validation committee and testified about them in front of our California Academic Content Standard Commission. His summary was, quote, The above standards illustrate many serious flaws in the common core standards, And also among those difficulties are that a large number of the arithmetics and operations, as well as place value standards, are 1, 2, or even more years behind the corresponding standards for many, if not all, the high-achieving countries. Consequently, I was not able to certify the core mathematics standard or benchmark at the same level as the standards of the high-achieving countries in mathematics. Indeed, Dr. Milgram is one of the people that could not sign off on the Common Core standards, and his letter is attached to the back of my testimony. I hope that you got a copy of, or you hold it in front of you. But those are people directly involved in mathematics. The next study comes from Dr. Andrew Porter, Dean of Graduate School of Education at the University of Pennsylvania. Now, Dr. Porter had done other comparative studies of state curricula. He is not a mathematician, yet listen to his conclusions. Quote, "Those who hope that the Common Core standards represent greater focus for US education will be disappointed by our answers. Only one of our criteria for measuring focus found that the Common Core standards are more focused than the current state standards. How much focus is desirable is unknown, but clearly the Common Core standards could have been more focused than they are. We also used international benchmarking to judge the quality of the Common Core standards, and the results are surprising both for mathematics and for English language arts and reading, ELAR. Top achieving countries for which we had content standard put greater emphasis on performance procedure than do the US Common Core standards. High-performing countries' emphasis on performed procedures runs counter to the widespread call in the United States for greater emphasis on higher-order cognitive demand." I would like to touch on this again a little bit, explain. Major theme running through the promoter of Common Core that they're supposed to be deeper and develop critical thinking. And I think all of us are for critical thinking. I don't know anyone who is against it. The big question is how one develops it. Now, some people believe that if we talk about critical thinking and throw big items at students, big and deep items at students, they somehow will develop critical thinking. Other people believe more like in music. You start with scale and you practice. And at a certain point, you are able to perform complex compositions. Same thing with mathematics. You do procedures and you become fluent and manipulating numbers and using numbers to solve problems, regular problems, and the depths and critical thinking develops from that. It has to be built on basic skill. And that's what Professor Porter mentioned, that all the high-achieving countries focus on performing procedure, which is building the skills before they dive into critical thinking. Yet Common Core seems to be focusing more on the critical thinking aspect without sufficient basis. Those are all studies that found the Common Core lacking. Yet recently, last year actually, there was a new study by Professor Bill Schmidt and Richard Huang from the Michigan State University that also compared the Common Core mathematics with curricula of other high-achieving countries. And in contrast with the other studies, their findings were different. Let me quote. "There being no major difference between the two sets of standards," they compared the 6 countries on the teams and the Common Core, "this provides further evidence that the Common Core state standards in mathematics are coherent and very consistent with the international benchmarks." In other words, in contrast with all the other studies, Professor Schmidt found that the Common Core actually is coherent and consistent with the international benchmarks. How can it be? I hope you have the handout, as I mentioned, because there are 2 pages at the back of the handout that are talking directly to the study of Schmidt. And unfortunately, I have to report to you that their study, which was published in a peer reference journal, actually, their conclusions are not supported by their own data and their own evidence. If you look at the page before last, there are two tables there, table on the left and table on the right. So it's named Figure 1 and Figure 2. Figure 1 is a picture of how a curriculum of the high-achieving teams nations looks like. And if you look at this table, it has rows that describe mathematical topics. And it has columns that are the grade levels, grade 1 to 8. Now, if you look at the order of the rows, you see that it starts with whole number meaning, whole number duration, basically with simple basic things to start very early. And it builds up. Mathematics is hierarchical after all. And as you see, it creates this characteristic triangular shape, kind of upper right triangular shape, that simple topics start early, more complex topics built on the simpler topics start late, and they progress through the grade, but no topic really lasts forever. This is a very characteristic shape that shows focus and coherent progression. The coherence is the order of the row. If simple topics come first, complex topics come later and then introduced later. None of them last forever, although the simpler topics obviously permeate everything, so they last a bit longer. So this shows, as I repeat myself, but coherence in the order of the row and the focus in the sense that topics don't cover all the 8 grades, but typically 3 or 4 grades at most. One learns them, one finishes learning them, and moves on to the next topic. Figure 2 is very similar mapping that Professor Schmidt did in this paper that is of the common core. And if you look, it's very similar shape. It's a bit thicker, but that's understandable. But overall, shape is very, very similar. So this was the main reason why in his paper, Professor Schmidt and his colleague said that the common core is coherent and consistent with international benchmarks. When he said international benchmark, he meant the team's countries on the right. And indeed, the shape do look similar. But there is a problem. If you go to the last page of the handout, you will see that Professor Schmidt reordered order of the rows on the right. In other words, Figure 2 with a common core, the rows are reordered compared to the original coherent order on the left. So suddenly, things like 3D geometry are introduced before 2D geometry basics. Things like relation between common core and decimal fractions are introduced before decimal fractions are even introduced. So let me repeat what Professor Schmidt and his colleague did on the right. They reordered the rows to get to this triangular shape, but suddenly they scrambled any coherence and sequence that was in order of the row because they wanted to achieve the illusion of the same shape. So this is a very misleading chart, and based on this chart and Professor Schmidt and Wurman conclusions, the proponent of the common core now claim, oh, we have evidence that the common core is indeed coherent and consistent with international benchmark. No, it is not. Even Professor Schmidt data, if displayed correctly, will show they're not similar. In summary, the middle school content of the common core falls 1 or 2 years behind our high-achieving international competitors, and they are not as rigorous and coherent as people claim. Let me move on now to the second issue, and this will be faster a bit, the issue of college readiness. A major reason for distance is that all of our high school students are now suddenly supposed to be college ready. Until the Common Core, high school graduation meant just that, high school graduation. Now suddenly it's supposed to mean college readiness. Yet our children have not changed. They are the same children, and we always knew that not every child is ready for college. But declaring that high school graduation will equal from now on college readiness, effectively, we had to dump down the college readiness, otherwise we would fail a major fraction of high school students, which is obviously politically unacceptable. So this is really what happened, but people that promote Common Core typically do not mention it. Yet it's not a secret. Jason Zimba, one of the lead authors of the mathematics standard, testified in front of the Massachusetts Board of Education in 2010 that the Common Core's concept of college readiness is minimal and focuses on non-selective colleges. Minimal and focuses on non-selective colleges. In other words, it's basically either community colleges and very few four-year colleges. The Common Core high school courses typically include only part of the content that you find in regular high school courses. So while the names are the same, Algebra 1, Algebra 2, Geometry, the content is typically lacking and partial. So it's a weaker set of Algebra 1, Algebra 2, and Geometry, even if the names are maintained. And consequently, if you have today problem with college remediation, students that are considered college ready with this new diluted content courses have an even bigger problem. Everybody requires these three courses at least, including Oklahoma, but the content will be diluted. Let me spend a couple of moments talking about the requirements for college. I mentioned already that typically it's Algebra 1, Algebra 2, and Geometry. But this is a marginal requirement, and we can see this from California data. California has a system where we test in grade 11 our students, and if they meet certain performance criteria, they are guaranteed to be placed in non-remedial courses in our California State University system. So we have been collecting data on this thing for close to 10 years right now. And the data is unambiguous. If you are only taking up to Algebra 2, students that are only taking Algebra 2 and then take this test, only 7% of them, very small fraction, is ready, considered ready for college, and another 22% of them are conditional ready. In other words, if they take another year of math, they will probably be ready. If, however, by grade 11, when this test is taken, a student has taken a course beyond Algebra 2, then suddenly the numbers are very different. 22% are completely ready and 67% conditionally ready. In other words, almost 90% are ready for college after a course beyond Algebra 2. In other words, Algebra 2 is marginal content to be ready for college. We say this is a minimal thing, and now we are diluting the content. Clearly, this is not something that will improve our college-going grades and college-going success. When Jason Zimba, this lead writer of the math standard, was asked about the meaning of the common college readiness, another thing that he said was, it is good for colleges that most kids go to, but not for the colleges most parents aspire to. Not only not for STEM, it is also not for selective colleges. For example, for UC Berkeley, whether you are going to be an engineer or not, you'd better have pre-calculus to get into UC Berkeley. Well, Common Core does not provide for pre-calculus content. So all the argument that we need the Common Core to be competitive in the global marketplace and for STEM and so on, this seems to be an empty talk unsupported by evidence. Finally, let me go to the last part of my testimony. What is the benefit of national standards? The national standards argue that they are important for comparability across states, to ease students' move across state lines, and economics of scales. There is also an argument that says, well, every high-achieving country has national standards. Maybe we should start with the last. It is true that every international high achiever has national standards. It is also true that every international lagger and unachieving country has national standards, because overwhelming number of countries around the world have national standards. Only a handful of countries, like the United States, like Canada, like Australia, used to be Germany, not anymore, that have distributed federal-like system of autonomous states. And they do not have necessarily nationalized curriculum. All the other countries do have. So by definition, all the successful countries, all the failing countries have national curriculum. It means nothing. Comparability is another issue that says, argues for having national standard. Yet we have comparability already, and we have had it for more than 20 years, 30 years. The National Assessment of Educational Progress, the NAEP, provide this kind of cross-state measurement, and we have been using it for many, many years. There is no reason to know that Johnny in Oklahoma, or Oklahoma City, how Johnny compares to somebody in Sacramento, California. That's not the point. The point is to know how Oklahoma City overall is doing against Sacramento, or how Oklahoma does against California. And we have it already. There are other ways also to do it. And many people have been using tests that are available across the nation, private tests like the MAP from Northwest Evaluation Association, and there are other possibilities. Cross-state mobility is a very small fraction, and to use it to justify nationalized curriculum seems strange. There is less than 1.7% of students that move across state line every year. This is the US Census Bureau data, and it includes military and everybody. 1.7% of students. And the argument that they will have a bit easier time to move across state line seems to be disingenuous. And economies of state, that may be an argument that is feasible for very small state like Rhode Island or Vermont. You are not such a small state. And in any case, many states can come together and decide to collaborate on purchasing agreement, on some other thing. But they don't need somebody from Washington to force them into collaboration and crack a whip if they misstep in this collaboration. In summary, the Common Core math standards are mediocre based on any international benchmark, despite claims to the contrary. Moreover, their prescriptive nature will require Oklahoma to replace much of its teacher training and professional development by content developed in Washington, D.C., and take away much of your teacher's autonomy in the classroom. Finally, the Common Core standards will tie Oklahoma's hands to Washington bureaucrats and will take your ability to care for your own children the way you want, rather than those people in Washington want. A year ago, in the face of the anti-Common Core rumblings in South Carolina, Ernie Duncan, our Secretary of Education, wrote, quote, the idea that the Common Core standards are nationally imposed is a conspiracy theory in search of conspiracy. A few months later, President Obama had a State of the Union, the 2013 State of the Union, where he said, quote, 4 years ago, we have started the race to the top, a competition that convinced almost every state to develop smarter curricula and higher standards, all for about 1% of what we spent on education each year. He's bragging about it, that the federal government got all the states to cave in on the chip for 1% of what they spend each year. Which one of them should we believe? Thank you for your time.
We are honored to have at least one of our senators with us today, and if there are others in the room other than Senator Sharp, we're glad to have you. So feel free to join into the Q&A. We're not sure if Dr. Wurman is going to be able to hear your question, so what we'll do is we'll try this once, and then if he cannot hear, I'll have to repeat the question so that he can hear it. So Dr. Wurman, are you hearing me just fine?
Yes, I am.
All right, thank you. Who is the first? Is it Representative Kern? All right, Representative Kern.
Thank you. Dr. Wurman, can you hear me?
Yes, kind of.
Kind of. Okay. You mentioned that the NAEP provides a comparative standard, yet I've heard that not all students have to take the NAEP. Will all students have to take the Common Core assessments?
Right. It is true that the NAEP does not allow to compare student to student, and that is not its role. The importance and the interest of the legislators is to understand how the systems are doing, and that's what NAEPs allow, comparability across states and sometimes across cities. And it does not need to test every student for that. If you want to know how Johnny in Oklahoma is doing versus Mary in California, yes, you need to test everyone. But why does it matter? You can adjust based on Mary's students in California or based on Mary's score in California, you can adjust it to the NAEP score if you want to, if you really want to compare them. But there is absolutely no reason. You can do it, but nobody cares.
Okay, may I have a follow-up?
Certainly.
Okay, you mentioned that the sequence of how mathematics is going to be taught is not always an appropriate one. I know you're not a psychologist, but does teaching things out of sequence, how does that affect a student and their learning?
I'm not sure I think I missed this piece about the sequence.
Yeah, Dr. Wurman, let me repeat the question. Basically, what Representative Kern is asking is if you change the sequence of learning in mathematics from the standard to what the Common Core would do, does that have some type of effect on the student? Would it have a psychological effect, or how would it affect their learning ability if you change the sequence of the standards that they're learning?
That's a very good question, because the answer is we really don't know. We know that if you make the sequence incoherent, it will not work. But by that, it doesn't mean that there is one coherent sequence, because in fact, there are many coherent possible sequences throughout the curriculum. And if you look at high-achieving countries, and you compare the curriculum of, say, Korea to Singapore, they are very different curricula, yet both of them are very successful. So we know that, teaching a student comparing A to B before you teach them what A is or what B is makes no sense. That's an incoherent curriculum. However, you can design multiple paths through the curriculum that are coherent, yet widely different and successful. So there is no one particular sequence that we know works.
All right, I believe that Representative Shelton is next. Representative Shelton.
Thank you so much. I don't know. Can you hear me?
So far, so good.
All right. Have you, before you came to do this testimony today, did you do any research into Oklahoma and to see what Oklahoma is doing in relationship to our schools? Or is this, or are your statements just broad across the just across the table? Is it just a broad statement, all states should be doing what you recommended, or is it, did you look at Oklahoma to see things such as how we're the worst state in per pupil spending in the country when making these assessments?
I'm sorry, the echoes made it hard to understand. Can you please repeat the question?
Let me see if I can try, and Representative Shelton, you help me. I think the question was, in preparing for your testimony today, did you do any specific research on Oklahoma and what we do here, or are your statements just basically across the board and would apply to all states, or are you considering our particular situation here in Oklahoma? Is that correct?
Okay, I thank you for the question. I actually did at your past standards. I read through them. I looked a little bit at your assessment, and I actually liked your standards, although I liked your standard, although what I was missing was a crisp definition of capstone goals. So I personally think that your standards could be improved a bit. But I like their clarity, and I like the fact that you have your major objectives specified for each grade level. Many states don't have this definition for each grade level, and they have just a list of standards, and then it's left to the teachers to decide what's important and what's less important. In fact, that's exactly the situation with the Common Core, that they don't have a list of priorities attached with each grade level, and that has to be worked out by either by the state or by local districts. And so in this sense, I find the Oklahoma standards very helpful, but they could benefit from additional clarity of the specifying the end goals of particular milestones in mathematical progression. I hope this answers the question.
You have a follow-up?
Yes, thank you. My question to you is if you have followed Oklahoma or done any research to Oklahoma at all, you know that we're worse in the country in per pupil spending. We cut more out of education than any state in the whole entire United States. The question, and I'm trying to frame it just right, is that you brought up California, you brought up Massachusetts several times during your testimony today. Is there any correlation in your belief that spending has to do is directly tied to quality of education that children receive?
If I understood you correctly, you are asking whether there is any correlation one can observe between the quality of the standards and the quality of the results, if you wish. That's correct?
That's pretty close, but good enough.
Okay. It's a complicated question and a complicated answer. I would say that if you have good standard, it is helpful to create good achievement, but it's not sufficient. On the other hand, if you have bad standards, or not so much bad as much as ill-defined or confused or unclear, it is very unhelpful to the system. But it's not necessarily going to cause a failure of the system, because the success and failure of system depends on many components. Depends on teacher training, depends on implementation in the classroom, depends on the standard, depends on the instructional materials. So if you have a small country, like Singapore, for example, where they have really one big teacher education school, you can actually have pretty mediocre standards, if you wish, or pretty fuzzy standards in terms of clarity, and still do very well because there is one body that interprets it for all teachers, so all teachers have a very coherent, very clear understanding anyway what is expected of them. So therefore the system will be very uniform and quite possibly good. Other countries that have also some very strong structure of understanding and homogeneity may not need very explicit standards because certain things are understood in this society, and therefore the standards don't have to spell it out. So for an outsider, it will look like those standards are lacking or are unclear, but in reality, they are good enough for that particular society. So that's part of an answer. But also you mentioned Massachusetts and California, and those are, I think, excellent examples because Massachusetts had very good standard and excellent implementation. And therefore, it moved from having mediocre achievement over time into having the best achievement in the nation. But it was not only because of the standards. It was also because of the professional development, because of the teacher training, because of teacher certification, because of good assessment. All together were needed to have this overall excellent success. California is the other example where you had excellent standards, but the system did not implement the teacher training, the professional development as well as it could. Consequently, the success of California has been much more muted. And I say success of California, even though a lot of people will say, what success? California is not successful. I'd like to correct this impression. In 1995 or so, California was at the bottom of the states in terms of NAEP achievement. It was number 2 from the bottom, I believe. Since then, California moved up maybe 10 places, so we are today maybe around number 10 to 15 from the bottom. Not a big deal, you would say. Yet, if you consider that at the same time, California underwent a significant demographic change. Our population of Latino students in 1990s was on the order of 40%. Today, it's over 50%. The Hispanic population typically has a lower achievement, and its share in the population grew significantly. Yet we climbed up from the bottom of the heap to somewhere a little bit above the bottom. If you consider the demographic change, we should actually be somewhere in the middle. Still nothing close to Massachusetts' success, but pretty decent and pretty impressive change. I hope I answered your question.
Did a great job.
One more follow-up, and then we're going to go to Representative Kern.
No, I appreciate that. And Mr. Chairman, thank you for your allowing me to ask these questions. The next question I have for you is, do you have any suggestions for rural and urban districts that are often forced to hire retrained, underqualified, and possibly temporary teachers to fill, to teach many of our math programs because they have such a hard time recruiting teachers into the state of Oklahoma due to the low pay and lack of resources?
Could you repeat the question, please, somebody there? I'm sorry, I missed the second half of the question.
Let me see if I can do this. In relation to some of the rural and urban schools that have to hire retrained teachers to fill gaps in the mathematics teaching, excuse me?
You forgot the word underqualified and temporary teachers.
Okay, retrained, underqualified, and temporary teachers to teach the math. So then what was the rest of the question?
Do you see any? Do you have any thoughts or suggestions on how Oklahoma can encourage math teachers, those highly qualified in math, to move to the state of Oklahoma when we're having such a hard time due to low pay and low resources for our teachers?
Did you hear that last part, Dr. Worman?
Not really. If you
Okay.
could repeat it, I would
So
appreciate
to fill these gaps in the math teaching positions, would you have any suggestion for a state, according to Representative Shelton, that doesn't pay enough? What can we do to recruit better teachers into the math sciences?
I don't really have a good answer for that. I can tell you that when California moved into teaching algebra by grade 8, it took us almost a decade to fill in enough qualified teachers in the middle school. It was a long process. I can tell you that the Common Core, while it is not necessarily more challenging or more demanding than anybody's curriculum or your own curriculum in this particular case, it does represent a reshuffling of content. For example, they push a lot of geometry into grade 8. So suddenly your middle school teachers will have to train themselves in geometry. Typically, they do not have any experience in teaching geometry in middle school, serious geometry. Not much, but they need something. Another example is that the issue of negative numbers that was typically taught in earlier grades, starting maybe in grade 4 or 5, now it's pushed into the middle school starting only in grade 6. So that puts the onus on middle school teachers to teach negative numbers, while the elementary teachers now don't have to teach it, but teach some other material about fractions and similar. So the reshuffling of content implies that there has to be done a lot of professional training if you adopt the Common Core, while the overall rigor and expectations of the system do not become necessarily higher, they become different. And that calls for a lot of professional development. And in my opinion, 40 hours or 80 hours is insufficient in most cases. Dr. Stotsky, who will follow me later, has much more experience than I do in terms of how to handle the professional training aspect. So maybe you should repeat the question to her. But beyond what I said, that there is a significant reshuffling of content without necessarily escalating the expectations is very important, I think, in mathematics.
Representative Kern.
Thank you, Mr. Chairman. Dr. Wurman, you, in your last answer, you mentioned geometry, and that's what my question deals with, because it was not addressed anywhere in your presentation. So geometry is being bumped down to the 8th grade, and what about the sequence in which it is taught? Will it be looked at in any other grades?
Excellent question, because geometry is indeed very strangely handled in the Common Core. It starts fast and furious in very early grades. So there is a lot of expectation, for example, of very young students in grade 1 and 2 to deal and characterize three-dimensional shapes, which seems premature and unnecessarily demanding and potentially confusing. Then it slows down, and it essentially meanders throughout the grades in such a way that areas of triangles and the sum of angles of triangles are touched on only in the middle school rather than already discussed and developed in the higher elementary grades. Then we come to the end of middle school, grade 8, where chunks of normal high school geometry are pushed down into the grade 8, Not many of them, but few of them. And more interestingly, they are pushed not only in terms of content. Congruence of triangle, for example, is discussed in grade 8 already, except that they also, the Common Core insists on particular experimental pedagogy to teach congruence of triangle. Rather than the traditional way of teaching triangle congruence, they are using what's so-called rigid transformations, which is a pedagogy that was tried in a couple of places around the world, and it failed. It was tried in Soviet Union in the 60s and 70s, I believe, and it was tried somewhere in Belgium at a certain point in time, and both of them proved to be abject failure, and they reverted very quickly from that. This is the method that is pushed in grade 8 and in high school geometry of teaching congruence. So as I said, part of it was pushed to grade 8 with this questionable experimental pedagogy. Then there is a geometry course in high school. Now, this is not your traditional geometry course. On one hand, it has a lot of algebra and algebraic manipulation pushed into it. So it's more analytical geometry than traditional geometry. There is much more focus on algebraic manipulations of geometric shape, which one can argue is good or bad, but it's questionable because the algebraic preparation of the students will be still weak. And this requires a lot of facility with algebraic manipulation. On the other hand, some of the more deep geometric theorems and topics are actually barely touched on in the geometry course. So it's a mixed bag of features, starting, as I said, in early grades, fast and furious, then slowing down and meandering until the middle school, then applying some experimental approach in the middle school, and then high school, which is kind of strange, a bit modified geometry from what we used to know. I hope this helps you.
Thank you, yes.
Dr. Worman, I have a question, and my question is, in your opinion, who is best suited to set the standards for their schools, the states or a group in Washington, D.C.?
I obviously believe that this is eventually the state's role to set the standards. It's perfectly reasonable to look at other people. But as I said before, there are many ways to reach the same goals. There are many sequences to reach the same goals. If I may offer something, a year or more ago, Bill Gates published a big op-ed in the Wall Street Journal. And his argument, I remember then, was, well, there is only, why should we have a different way to teach children how to do some arithmetic operation? I don't remember. Maybe he was talking about multiplication of numbers, or adding and subtracting. And his kind of common sense question was, why should there be so many ways to teach addition and subtraction, say? And on the first reading, it made sense. On the second reading, it made absolutely no sense, because we do not know if there is a right way to teach addition and subtraction. As I said, you look at Korea, you look at Japan, you look at Taiwan, you look at Singapore. They're all highly successful, but each one of them teaches math differently. So yes, we know that we more or less want to get somewhere at about some time, but not precise time. But how to get there, we have no idea. And I believe each state should have the right and the obligation to try to do the best by their own children, while looking outside to learn from them.
Well, Dr. Worman, we're about out of time and need to take a break. I want to thank you so much for presenting to us today and taking your time, and all of you have asked questions. Thank you so very, very much. So with that, we will take a break, 15-minute break.
If I may, one thing.
Yes, sir.
I wanted, obviously, to thank you, but I also want to correct the record. I am not a doctor, and didn't want to start from that, but I don't have a PhD, so please remember that. Thank you.
All right. Let's take a break. We'll come back in at 2:15.